Okay, thank you. No, and I'm just going to kind of refer back and review what we did at the end of class. So basically, if you have a polynomial function, you want to know what a polynomial function is. Polynomials kind of look like this. This is a good example. You have powers of x, whole numbers. What are whole numbers? Like 0, 1, 2, 3, so forth like that. So if you have if the highest power is odd, then the graph either does this, okay? It does one of the two. So if the number in front of the highest power is positive, then it does this. So your graph's going to go like the hula dancer there, okay? All right? Now, the next thing on this next page is if you change that and you still have an odd degree polynomial, if you have a negative, then the dancer goes like this, okay? So that it's helpful to know that for limits, then you can do some of these problems very, very fast. Then we have even powers. So if your highest power is even and the number in front that we call the leading coefficient is positive, then the dancer does this, okay, like a parabola, okay? And then if you have the same thing even, but a negative leading coefficient, that reflects it and makes the graph go like that, okay? That's stuff that typically you might learn in college algebra or finite math. It's kind of easy to forget. But once you have that down, it'll be real easy to do these limits, okay? And partially what we're doing here is getting you comfortable with functions, because that's what we talk about the whole semester is functions. So let's go to the next page, and let's just kind of work out just a few of these things here. Now, what you want to do on these, your goal on these problems is just to know the answer, okay, quick and efficiently. So first of all, this one, we're not going to do a graph on our calculator. We're just going to sketch how the endpoints go. All right, is this an odd degree or an even degree? So what does it do? We know it does this or we know it does that, okay? Well, that's a negative. So if it's a negative, then it does this. So just all I want you to do is just sketch that. That's good enough. That's all you care about. What happens in the middle doesn't make any difference, okay? They're going to connect some way. So what this means is if we're looking at the limit as we go to negative infinity, where's the graph going? If you're going to negative infinity, where is y going? Positive. To positive infinity. Good. So the answer to that's positive infinity. See what I mean? Okay. Now the next one, okay, we're now looking at a limit as x goes to positive infinity. Well, if x is getting bigger and bigger, where's the graph going? To negative infinity. So the answer to that problem is negative infinity. That's it, okay? You don't have to do it on a graphing calculator. Based on what you know about the endpoint behavior, you can easily figure that out. Does that make sense to everybody? Okay? All right. So how about the next one, okay? How's that one going to go? Like this, exactly. Okay, it's an even power. Number in front's positive, so we know this one is going to look like this. Okay, well, there's one other thing that's kind of nice to know on these things. Like on a polynomial, that constant term, you might want to understand that that really is a y-intercept. So that's down 3. On this thing, that's also a y-intercept. It's nice to know that, although it doesn't have any impact on the limit. But that's kind of what your graph would look like, okay? So what's the answer to the limit as x goes to negative infinity? Okay, that's equal to positive infinity. How about if x goes to positive infinity? Still positive infinity. Everybody with me there? Okay, all right, that's it, okay? All right, now let's look at these next two here. So, all right, this one, fifth power, how's the graph go? Like this, okay? All right, you got to know which one it does. So the idea is since that's a positive number right there, so that's a positive x to the fifth, that means the graph goes like that and goes like that, okay? This actually would have a y-intercept of -1, like that. So what would be the not the left-hand limit? When x goes to negative infinity, where's the graph go? Negative infinity, good, okay? And if x goes to positive infinity, where's the graph go? Positive infinity. Everybody understand what I'm talking about here? Okay? Okay, very good. Okay, next one, the graph on this is going to do what? Like this. Down, kind of like a downward parabola, sort of. Okay? So it's going to go like that, like that. It's going to have a y-intercept of -1. So you're going to have something like that. So what's the answer to both of these limits? Negative infinity. Good. Okay? All right, so when you're doing these kind of things, you'll see some of this on your homework on My Math Lab. You just do them in your head. Okay, the knowledge of that is you want to get comfortable with polynomials. We're going to deal with polynomials in economics applications quite a bit, and we'll kind of look at some of that today a little bit. Okay, so here is, to finish up, I want to look at this problem right here, and you can kind of tell me how much of this you may have learned in finite or college algebra. If you took finite, you probably learned more about this than you would if you took college algebra. So I want to do just kind of one application. We'll do a lot of business and economics applications in the class. So this one is saying that you have a company that is manufacturing snowboards, and this is how much it costs per day to run this operation. And what we call this thing is we call that a fixed cost. Okay, and that's a good thing to make a note of. That just means, okay, that's regardless of how many things are being produced and sold, that's a flat fee, okay, right there. Okay, and then it says a total cost of $3,800 per day for an output of 20 boards like that, okay? So we have to kind of put together a function like this. So the basic idea with this goes like this, all right? So first of all, your function, and we're going to find a function for c of x. That's going to represent the cost. Okay, it goes like this, okay? A cost is going to go like this. You might want to write this down like this. It's going to be a variable cost plus the fixed cost. Okay, that's the way that a cost function's generally going to work. It doesn't have to be a line, but in this case, it's like mx plus b. Okay, so I'm just going to write this kind of like just mx plus b. It's a line, okay? So what you have is this fixed cost. That's what your y-intercept is, okay? That's what this is. So you want to plug in there a 200, okay? Now what we need to do on this is it says the total cost is $3,800. Okay, so I'm going to bring that down, and that right there is going to be $3,800 like this. Okay, we don't know what the slope is, but we do have to figure this out. And then x is going to be this piece right there. That just means 20 boards like this. So the way that a cost function works, if it's a line, is you always have like a fixed cost, okay, and then you always have a variable cost. So what we need to do is figure out how much it costs to produce one of those boards, okay? So what we're going to do is we're going to solve this equation to do that. So let's write this down, and this will be a real simple equation to solve. So we'll have 3,800 equals m times 20 plus 200. Okay, like that. Now what you want to do now is you want to go ahead and solve that equation. You want to get m by itself on a side. So we could subtract 200 from both sides. That's one way to do that. Okay, that'll give 3,600 is equal to 20m. And then what would you do? Of course, divide by 20. Okay, so if you do that, you've got m, and what that represents is that's like the slope, but it's also giving a variable cost. Okay, it's given a cost per item. So if you do that, let's see, that zeros would cross out. So what is that, 180? Okay, so that's what you get. So what we're going to have then for part A on here is we're going to have this cost function. We have c of x equals m. We just found m to be 180 times x, and then the variable cost was 200. Okay, so here's what this really means. And you want to make sure that you understand this. X is how many, what were we doing? I forgot, snowboards or something? Okay, so if you sold one snowboard, how much would it cost? 180 plus 200, right? Okay, if you had two snowboards, it'd be 180 times 2 plus 200. The cost is going to go up like a line, but that fixed cost is always there. That doesn't change. This part right here is the variable cost. Does that make sense? Okay, everybody. Okay, so you had to do that work over here to figure this out. Now we should be able to go through and answer these questions on here like this. So let's go ahead and finish up. Okay, so that's the answer to part A then, is we have that particular cost function, okay? And then part B is we're going to do what we call an average cost, okay? Now the average cost, and we're going to do this quite a bit during the semester, we usually write it as C bar. That means average. If you've ever had statistics, or even if you haven't, Some of you may know that if you see X bar, you know what that means? This means the average. Okay, it's like the arithmetic mean. So what we do is we just do this. We just take the cost, which we just got is 180x plus 200, then you divide it by x. And what you're doing by this, see, this numerator is the cost. This is just basically the number of items. So what you're doing is you're taking that cost and then you're dividing it by the number of items you sell, and that gives you an average cost. Okay, does that make sense? Okay, now you could leave the answer that way, but it's probably best for what we will eventually do with the calculus to split this apart and write it this way. So I'm going to write this as 180x over x plus 200 over x. Okay, now again, really this is okay to write your answer that way, but you can split fractions apart. Because after all, how do you put fractions back together anyway? If they have a common denominator, you just keep the denominator and put it back together, right? And what happens to the x's right here? They cancel out, okay? So what we write then is we'd write this like this. We'd say c bar of x is equal to 180, and then you could write that as 200 over x, like that, okay? That's another way to write the answer. I like you to go that far, because when we start learning about what we call a derivative, which we're going to start into a little bit today, then you have to write it in that form to do the derivative. It makes it a little bit easier. Okay. All right, now let's do this on the calculator, and I'm not going to necessarily have you sketch. I'm going to have you do a real rough sketch. So get your calculator out, and what we're going to do is we're going to graph this cost function. Okay, so let me move this over here so you can see it okay. All right, so let's put this in, okay, this thing right here. So let's go to y equals, okay, I'm going to take out whatever mess I got in here. Then I'm going to do 180 plus 200 over x like that. So we're going to graph that, okay?
200 over x in parentheses, or is that matter?
No, it doesn't have to be. And the reason is because 200 is just one thing and x is one thing. If you had x plus 1, then you would have to have that in parentheses. So if you just have one number and one number in the denominator, you don't have to worry about it. But to me, it's always safe just to put parentheses if you're not sure. Okay, now what I'm going to do from here is the window. If you read the problem, a lot of times you're given something on that. So 1 to 30. So what I'm going to have you do, let me fix this thing up so it does this right. You want to go ahead and do your window. And instead of doing 1 to 30, let's just go ahead and do 0 to 30, like that. And then we can scale that. What's a good scale? If you're doing a graph from 0 to 30, you could go by 5s or 10s. That's a logical way to do that. So let's go by 5, like that. Now, when you do your y's, a lot of times students struggle with not knowing what to do for y. What I always recommend that you do is look at your table of values to see what kind of y values you got. So go second graph. And if you do that, it'll give you a good idea of what your y's look like. So notice that you're going to have an error. You are undefined at 0, and it looks like the biggest value, I can't read that. Does that say 380 or something? So let's go maybe, and see they're going down. You see that the numbers are going down. So a logical window would be for y would be to do this. Let's try this, and I'll slide this to the side so you can do this. Let's go 0 to 400. Like that, and then let's maybe not 4,000. Sometimes this thing doesn't type very good. Puts in an extra 0 when I don't want it to. Okay, and then let's scale that by 100, like that. Okay, so that would be a good viewing window to put in.
Yeah, but it's 1,000.
What's that?
Your scale.
Oh, forget the scale. See what I was talking about? Okay, let's try 100. Okay, so let's put that in like that. All right, so now, go ahead and graph it. You should see it kind of start high, and then you should see the thing kind of leveling off, almost like it has an asymptote. It actually does have an asymptote to it. Okay? So let's do this. I'd like you guys to just, anytime I want you to sketch a graph, this is kind of what I would want to see. Okay? I would want to see that you label your x and y axis, but in this case, this is really c of x. Okay? And then you'd want to put this like this. You would want to say number of, what was this? I keep forgetting. Snowboards? Is that what it was? So number of snowboards, you want to represent, I mean, if you're a business person, you don't want to give graphs unless they are very clear on what they're measuring. And then this would be the average cost. And that should be a C bar of X right there. So that would, you want to just say that's the average cost. Okay. And then you're just going to make a sketch on it. So it looks like our X was going all the way up to 30. And you could even do this like this if you wanted to, 10, 20. You got to label stuff too. And then your Y's were going up to 400. So we can just kind of label that like 100, 200, and so forth like that. Now, for our purposes, you can go through and just kind of roughly sketch this. So what's going to happen is it's going to look something kind of like that. That's a very rough sketch. It doesn't have to be perfect, but you can use your calculator to get, you know, as many points as you want to like that. Okay? So that's the idea. That's the graph. Everybody with me on how I'm doing the calculator? Okay? Everybody seems like they have different backgrounds with these calculators, but they're great tools to help you understand things, to me, in calculus and in algebra and so forth. Okay, now we got one last part of this. Okay, this says, what does the average cost per board do as the production increases? So what's happening to the average cost? It's going down. Now, is it going down? It's going down forever, but it is leveling off. Okay, so as this goes to infinity, I wonder if you guys would know what that limit would be. If you did this limit of that function as you're going to infinity, do you know what that would be? 180, right. Because this part right here, that part right there is actually going to 0. If you do 200 divided by an infinitely big number, it just gets close to 0. So it's 180 plus 2 plus 0, so it's 180. So one other thing I want you to write on here is this. And I think on your assignment you turned in today, you had a problem kind of similar to this. If you're doing the limit of 180 plus 200 over x as x goes to infinity, now you can do that in your head, but technically what you're doing is you're doing the limit of 180 as x goes to infinity plus the limit of 200 over x. I'm just kind of showing those limit laws, okay, like this. What's the limit of 180? 180, right? Because if you graphed 180, what would it look like? It'd just be like a line going that way, right? And then this right here, see, the degree of the top is less than the degree of the bottom, so that's why that goes to 0. So you would actually have 180 plus 0, so it would be 180, like that. So that's what's happening on your graphing calculator. That thing is leveling off at 180, okay? I'm going to show you one other little quick thing on the calculator here. You don't have to do this, but if you put in y2 180, you'll see what I mean. Okay, so if I graph that, that's going to be your horizontal asymptote. Okay, is that clear with everybody? Okay, so you use limits a lot of times in business to kind of see where something is going as your production increases. That's one idea. Okay. All right, any questions about what I did on anything with that problem? Everybody following along okay? Okay, all right. Okay, so last thing I want to do is I want to give you guys a few minutes to just work these out. This is the last page. I want you to look at the graph and then just see if you can answer those limits based on the graph. Okay, so go ahead and work on that for a few minutes, then we'll see if we're on the right track, and that'll wrap us up. Okay, let's see what we got on this one. Okay, so how about number 9? What do you think the answer is? -2, absolutely. So as you're going to infinity, the graph is leveling off at -2. Remember, when you do a limit, you're always doing a y value. Okay, how about number 10? What's the answer? Infinity, exactly. What's happening on this one is, as you're going to the left, what's the graph doing? Just getting bigger forever, right? So you'd say infinity, okay? All right. What kind of limit is number 11? Right-hand limit. So that means you're looking at -2, and you're just looking at what is the graph doing as you're closing in from the right. So what's your answer? Negative infinity, good. All right. What kind of limit is number 12?
Infinity.
Left-hand limit, okay? So what's the answer if you go to the left of -2? Positive infinity, like that. Okay, everybody solid with what I'm doing? Okay. All right. Now the next one we're looking at -2. So this is a two-sided limit like we talked about. What's the answer to this? Does not exist. They don't go to the same place. So that one does not exist. You can always just abbreviate that like that. Okay, next one is a right-hand limit. What'd you get on this one? Infinity, yes. If you're going to the right of 2, I'm going like that. I'm getting closer and closer to that asymptote, but the y values are going to infinity, like that. Okay? How about the left-hand limit around 2?
0.
It goes to 0, exactly. Just gets close to 0. So therefore, what's the answer to the two-sided limit? Does not exist. Okay, so that kind of wraps us up there. Everybody got that okay? Any questions about that? All right, very good. Okay, now we're going to go on